I want to make a quick video to address the question of how do I know when to use the disk washer method versus when to use the shell method. And so now we've covered each one of those topics separately. But what if you get a question where it just says find the volume of the region rotated about a specific axis or line, but it doesn't tell you to use either method. And so a student asked me this question. I wanted to make this short video to just kind of address it. So we see an example here. It says set up an integral to find the volume of the solid formed by rotating the region bounded by y equals x squared minus 4x plus 5 and y minus x equals 1. And there's two parts. Part A says we want to rotate that about the x-axis, and then part B says we want to rotate it about the y-axis. So as with all the problems we've been doing, we want to graph first. And so you can see down below here that I have graphed both curves, and one's a line and one's a parabola. And really the very first thing we want to do is we want to determine, is this a vertical, a bottom to top region, or is this a horizontal left to right region? And so hopefully you've done enough of these that you're now able to recognize the difference. This is definitely one where we want to do a vertical representative rectangle, and I'm going to go ahead and draw that in here. Here's our region, and if I draw that rectangle, we can see that the blue curve is always on the top of this region, and that the red curve is the yellow curve is always on the bottom for this region. So again, here's my region. I got my vertical rectangle there. Of course, if it's a vertical one, that means our integral is going to be with respect to x, because that's the thickness, right? The thickness is in the x direction. And so that's the main thing. Like once you have that, determining whether to use shell versus disk washer comes down to remembering those two words I told you we talked about in, I think it was section 2.3 video. We talked about, well, they're not really words, they're made up words, but parashell versus perpendicular. Right? So if you take, for example, part A, it says we want to rotate about the x-axis. Well, I already have my rectangle in there, and if I'm rotating about the x-axis, that means that rectangle I drew is perpendicular to the x-axis. So which method am I going to use if it's perpendicular? Perpendicular. So I'm going to use the disk method, which is sometimes the washer method. And in this case, it actually is going to be a washer because there's a hole, and that's because there's a gap, right? There's a gap between the bottom of this representative rectangle and the x-axis. So we have an inner radius, and we have a outer radius, which is gonna, and so here's our little r right here. And then the blue curve is our big R. And so if we were to set that up, well, first of all, we can see that x goes from 1 to 4, right? So that representative rectangle is going to slide from left to right between 1 and 4. And so we're going to have that the volume is equal to the integral from 1 to 4 of pi. Actually, let me put the pi out in front. So pi times the big radius squared. And again, the big radius squared is that blue function, and we're in terms of x. So we do need to go ahead and rewrite this blue function. That one is going to be y equals x plus 1. So we have the radius x plus 1 squared, this is big R, minus the inner radius, the little r, which is the red curve, which is x squared minus 4x plus 5 squared dx. And it's as simple as that. Now, of course, to evaluate it, you'd have to do a lot of algebra there to kind of multiply all that out, but we're just taking big R squared minus little r squared. That's all we're doing there. And it's the washer method because that representative rectangle, again, is perpendicular to the axis of rotation. Now, if we were to rotate about the y-axis, now that same representative rectangle is now parallel to the y-axis. So we are going to have a shell method now because it's parashell, right? So I'm going to draw the shell that would be formed here. Looks like we get something that looks kind of like that. Right? So that's kind of the idea there. And so our radius here, this is our radius, r. And then our height is basically the height of that representative rectangle, which is going to be basically the difference between the blue function and the red function. H is going to be the blue function, x plus 1 minus the red function, x squared minus 4x plus 5. That's our height. And then our r is the x distance. We want everything in terms of x, right? R is the x distance to the curves. And so our volume is going to be, using now the shell method, our volume is going to be still going to go from 1 to 4. We have 2 times pi. And then we have r, which we know is x. And then we have h, which we already determined was the top function minus the bottom function. And that's it. That's it. You would not want to use, if you're rotating about the y-axis, you would not want to use the washer disk method. And if you're rotating about the x-axis, you would not want to use the shell method. The method is determined by which axis you're rotating about and whether or not your rectangle is perpendicular or parallel to that axis. If you're still confused, be sure to hit me up, make an appointment, and we can talk about it further. But hopefully that cleared some things up for everyone. Have a great day. Thank you.